Hello and welcome back. In the previous video, we saw that what is embedding encoding. And in this video, we are going to see a simple example. This example will be really simple because the embedding things are basically related to the neuro-linguistic programming and it's all about the neural network things, right? So here, since we don't have understood all about the neural networks, so the example will be really simple, right? So here you can see we have imported the NumPy library and then we have imported the Keras library, and from the Keras library we have imported the embedding module, the model module, and from the layers we have imported the input module, right? And then we have imported from the TensorFlow, we have imported like pad sequence, right? How to give a sequence to the set of words, right? So basically we have given here three sentences. You can see that there are three sample sentences. If you want, you can stop the video and you can type the code yourself. But yeah, you must need to remember that you must have to import first the PIP install. You need to do the PIP install for these things like TensorFlow and it's like Keras or NumPy, right? So these things should be with you. You should be able to install them. So once you install them, then you will be able to run this program. So here are three sentences. The purpose is that we have to define a model which can predict a sequence of the words. You might have seen that when you write something like hello or hi or good, then obviously it is going to suggest you some of the words. In today's era, if you see, while you are writing the mail, if you write like hi, good, then after writing good, it suggests you morning, evening. Based on the time itself, it suggests, right? So it's evening, morning, hi, hello. After that, whatever word should come, it gives you a suggestion. So from where that suggestion is coming, those suggestions are coming, after the training of a machine learning model, which is using this pad sequencing. Something like pad sequencing, not exactly the pad sequence, but yeah, something like this, right? So here are the three words: hello, world, world cup, and then cupcake. So if you see, there are overall unique words: one, two, 3, and 4. There are four unique words: hello, world, and then cup, then cake. So these are the four words, right? So these four words are nothing but the tokens. These are known as the tokens. Okay. So yeah, here we are going to split these sentence into the words, right? So let me just close all of, comment all of the print statements. One by one, we will open these print statements. So here we are going to, yeah. So model dot summary, this also I don't want to show. So let us run and let's see the first thing, like what are the words which has been tokenized, right? So if you see this thing, yeah, hello world, World Cup, cupcake. So these are the tokenized words. So basically, when it has tokenized it, then in that case, it has splitted each and every word in this sentence list, and it has created a list of lists where the each of the token has been given a specific place, right? So all the tokens have been taken and they are, they have been kept into a separate list, right? So hello and world. So if there was something else, then there could be having one more word here in the list. So inside the list there are lists. So this is a list of lists. So basically it creates a list of lists. This thing I hope you know about the Python, so I'm not going to explain this. What is this? We have printed just the words. Now let us remove this. Now come to the this thing, right? Like what is the vocabulary? How to create a vocabulary? Vocabulary means what? You have these words: hello world, World Cup, cupcake. If you create a vocabulary, how many words will be there? There will be only four words. One is hello, one is world, the third one will be cup, and the other one will be cake, right? Because there are repetition of the words, like world, this word has been repeated, cup has been repeated, cake has not been repeated, right? Cup has not been repeated. So hello has not been repeated. So whatever has not been repeated means the unique words, they create the vocabulary. I hope you are understanding you're understanding this fact. What is the vocabulary? So vocabulary is nothing but the set of unique words which has been used in a particular language or in a particular literature, right? Suppose you are working on the English literature, then whatever inside this literature, whatever has been written, they all exist in some kind of vocabulary. All those words have been mentioned in Oxford Dictionary. Those are the unique words, right? So there the unique words have been mentioned. So if you are creating the vocabulary, obviously you are going to use the set, because set is the unique set of unique collection. Set is the unique collection of elements. So here the elements are the words or the tokens. So if you print the vocabulary, this vocab, after this vocabulary, after creating this vocabulary using the set function, because in the set function what you are doing, you are passing all these things: hello world, world cup, cupcake, everything you are passing. So once you are passing in here, it is getting the unique words or unique tokens and assigning it to a vocab, right? Let us see what is this vocab. Is this a list, or is this something else, right? So let's see. So we are going to print vocab. Okay, so here you can see the vocab has been created: World Cup, hello, and cake. So unique words have been collected here, right? And now the length of the vocabulary has been taken here, right? So that could have been used later on. So now in this line, we are doing the mapping of the word to index mapping. So for every word, we are going to give a unique index. For hello, we will be giving a unique index. For world, we are giving a unique index. It will be 0. For cup, we are going to give unique index. It could be 1. For hello, we are going to give a unique index. It could be 2. And then we can give a unique index to cake. So it will be 3. So 0, 1, 2, 3, something like that. The indexing will be done and the words will be mapped with the particular index, right? So this is the way you need to write it. So again, this is the syntax of the Python language. I'm not going to tell you this one. So here we are going to print the word with the indexes. What word has been, mapped to which index, that we are going to see here. So let me run it. So world, it has been at index 0, cup at index 1, hello at index 2, and the cake at index 3, right? So now let me remove this one and let's come here. Convert sentences into index sentences. Let us see what this index sentences is. So we are going to do this like inside the word index. In with every word, what we are going to do, we are going to find out a index sequence, in what sequence these words are coming, right? So let us see what does this index sequence is giving to us. Index sequences QU. Okay, here I am missing. That's why I was thinking why it is not giving me. Okay, so 200113. So these are the index sequences. After 2, 0 is coming. What was 2? For which 2 was aligned? 2 was aligned with hello, and world was aligned with 0, because for the world we have given the we have given the index 0. So let me put again this vocabulary, or let me print it again so that you are able to understand it correctly. Okay, so if you run it, two things will be there. So world, cup, hello, cake, right? So we have three sentences. So for these three sentences, it is going to map like in what order it is coming. So it is coming in the order like, this two is, okay, let me print not only vocabulary, I need to print this indexing. I just forgot, I need this print word to IDX. Okay, let me run it. So if you run it, for world we have given 0, for cup we have given 1, for hello we have given 2. So if you see the very first sentence, it's like hello world. So for hello, what we have given? 2. You can see here. For hello, we have given 2, and for world, we have given 0. So it has given like this 2, 0, and 0, 1 means world, cup, and then 1, 3 means cup, cake. It's very easy. So it has been done in this manner, right? So this is the way index sequencing has been created. So let us now remove these two. Maybe it could be needed, so let me keep it as it is. Okay. Now we are going to create a padded sequence. Let us see what is the padded sequence. Print here, padded sequence. Okay, so here we are creating a padded sequence. Let me, okay, padded sequence we were already printing, right? So let me uncomment it. Okay, so let us see what does padded sequence give to us. Okay. Okay, so padded sequence, for the padded sequence, what we have given maximum length 5. What is this maximum length? In the previous video, we have seen that in case of embedding, what we do, we take the input dimension. The input dimension we will take in full. Whatever dimension is there for the inputs, that we are going to take. But the output dimension will be as per our choice, right? In that output dimension, we will be looking like how many things are in proximity, what things are in the proximity. Based on that, we are going to provide the weightage to each of the word, or to each of the token, right? So that's what we are going to do. So here, what we are going to do, we are going to create a pad sequence of maximum length 5, right? We are going to create a padded sequence of maximum length 5. So that is why you can see in every array, like for the 20, it was hello world, but you can see three more are there because we have padded it with 5. So these are the 5 elements you're able to see. So hello world, 2 and 0. Only these two are important. In the beginning, only two are important, right? This is just an example, because here you could see that we have given the length 5, which is more than the input dimension. But the thing is that in the this will be the real modus operandi when you will be converting your dimensions to lower dimensions, when you are going to map it, when you are going to do the embedding, right? So hello world and then cupcake, sorry, it's like world cup, so 0 and 1, right? Then comes cupcake. So cup is 1 and 3 is cake. But rest of the three elements, they will be padded with 0, because you have given the max length as 5. Padding, for the padding sequence, you have given the max length 5, right? You are going to give a input layer. So input layer, let us print the input layer. Input layer, let us see this one as well. What is this? So this is the one input layer, and let's print it. So input layer, it's like it's 5. Type is float. We are not we are not sparsing it, right? So we are using Keras tensor. This 14. This is the internal name, whatever it has been given. So this is how we can see. Like input layer has, in the input layer we are going to provide 5, maximum length 5. Let us remove this. Now come to the embedding layer. In the embedding layer as well, we are giving the output dimension as 5. That is why you were able to see the 5. So let us see the embedding layer, right? So for the embedding layer, you will be able to see again the same thing. Okay, so embedding layer we are going to print. So embedding layer, it's 5 cross 5. So it will be 5, 5, and then float type, and then we are going to see this. Okay, we are going to see that how it is visible here. So ultimately, after these embedding layers and all these models, model preparation, input layer is inputs, and embedding layer is in the outputs for the model. Now after compiling the model, we are going to create a summary of the model. So here is the summary of the model. Total parameters 20, right? So 20 are the total parameters based on the, this one. And then trainable params are 20, non-trainable params are 0, which means every parameter is trainable, right? So total params are 20, trainable params are, 20, and then non-trainables are 0. So 80% of them, they are the part of the 80% data. So total parameters are there, so which will be used for the training, and which will be used for the total number of parameters. So entire parameters are trainable. I mean, nothing can be left. Every parameter here is trainable, whatever we have seen, right? So input layer is the is of shape 5, and the embedding layer is of shape 5 cross 5, right? So it is total number of params, it is containing is 20. 5 cross 5, although it becomes 25, but yeah, the parameters, total overall it contains is 20 only, after the converting it, right? After converting the things, it is creating a 20 parameter. So it is doing nothing, but when it is creating the 20 parameters, or you can say that 20 values it is providing, then it is just calculating the proximity, right? So that proximity, that in the previous video we have seen that not everything will be kind of zero. Here you can see everything is zero, but the thing is, this is just the padded sequence. This is not the final sequence. Final sequence is here, like in the embedding sequence, in the embedding one, right? So these are the layers which have been mentioned here. So this was the basic example that how the embedding layers are created from the input layer, right? Input layers and embedding layers, how they are decided. And there are 20 trainable params. They are really important for training of the data, right? So that has been mentioned here. So you can see the previous video and then you can come to this code. Not much can be explained with respect to this code because that kind of thing will be needing a kind of understanding in neural network as well that you don't know. So if you are not able to grasp this complete video or maybe the complete explanation, don't worry about it. In the coming videos or when we will reach out to the topic of neural network, neuro linguistic programming, for that, when we will be discussing, then in that case, you will be able to read it again, study it again, because I'm going to create another playlist for neural networks. There I will be discussing all these things. So be with me on the feature engineering playlist as well, and we'll soon create another playlist on the neural networks. So I hope you must have understood to some extent. And if you are able to understand the previous video, then you will be able to understand that what these 20 values means, how they could have been calculated, how they could be looking like, right? Because we are not printing these arrays here. But yeah, there is an embedding layer which contains some data, right? So all that will be printed. So we'll meet in the next video with a new topic. Till then, have a nice day and bye.